Fast-paced and globally connected, yet more and more separated. Separated from what? This is a brief story about two opposite worlds. One natural, one artificial. One cyclic, one virtually eternal. The aquatic environment and microplastic pollution. Tons of plastic entering our oceans every year. Never degrading, never disappearing. Most microplastic waste originates on land and travels through rivers to the ocean, coming from synthetic textiles, road runoff, and city dust. Current solutions are very limited. Wastewater treatment plants even worsen the problem, as seen at the Lambro River in Italy, where microplastic levels were 7 times higher near a treatment plant, flowing downstream into the ocean. What if the solution already exists in nature? What if one system could not only filter microplastics, but digest them too? The biggest inspiration comes from the Manta Ray, a natural filter feeder that swims with its mouth open to consume plankton, filtering particles as small as 0.2 millimeters without ever clogging. MantaFlow is a modular product consisting of 4 parts: a debris cap, a Manta Ray-inspired filter, a sea sponge-inspired digestion area 3D printed from a PHA flax composite where native bacteria and fungi break down the captured microplastics, and finally the outlet. Water passes through the filter chamber, capturing microplastics, then into the digestion chamber where they are broken down, before leaving the system clean. MantaFlow can be placed strategically in any location and stacked together to scale up filtration capacity. In the future, MantaFlow units can be spread across rivers near populated areas or microplastic sources such as wastewater treatment centers, maintained and monitored as part of a larger solution. There are still open questions around the efficiency of the system and the well-being of the bacteria colony. This is why MantaFlow is designed to be easy to manufacture, disassemble, and modular, so it can be easily tracked, maintained, and improved through time. Even a complex problem can be solved by simple design, inspired by nature.